Hi guys, and welcome to the video on the Pythagorean Theorem and its converse. I know you guys have done the Pythagorean Theorem before, but we're just going to kind of do some review and talk about a few other things that maybe you haven't done before. So let's just start off with the basics, the Pythagorean Theorem. Okay, so basically we have this triangle over here on the left, triangle JKL. So if triangle JKL is a right triangle, then that means that a squared plus b squared equals c squared, right? That's the thing that you guys know, okay? So if anything is a right triangle, that means that the squares of the two sides are equal to the square of the hypotenuse. Okay, and then really the thing to talk about is the triples. Okay, so the most basic right triangle is going to be a 3, 4, 5 triangle. Okay, now a triple means that those are the three side lengths that you know that 3 squared plus 4 squared is 5 squared. So now what you can do is you can multiply this triple by any factor. So you could multiply it by 2, so a 6, 8, 10 also works. You could multiply it by 3, a 9, 12, 15. You can multiply it by 4, by 5. Okay, so if you can simplify those three sides to 3, 4, 5, then you know that you have a Pythagorean triple. Another triple is the 5, 12, 13. And you can do the same thing with that, with doubling everything or tripling. Another one is 8, 15, and 17. And the fourth one is 7, 24, and 25. Now, it's not important that you memorize those, but it's just good knowledge for you to have because it makes things a lot easier. So in a lot of cases, if you know that these are already Pythagorean triples, you don't have to go through the work of using the Pythagorean theorem because you know, based on this information, that it will automatically be a right triangle. Okay, so on this first one, it tells you to find the missing side of each right triangle. We don't have the hypotenuse, so this is C. Okay, we know that 7 and 9 are both A and B. It doesn't matter. So we'll start off, first of all, by saying that we know that the Pythagorean theorem is A squared plus B squared equals C squared. Okay, so we have got 7 squared plus 9 squared equals C squared. 7 squared is 49 plus 81 equals C squared. And then 49 plus 81 is 130 equals C squared. Alright, so up to this point, it's been fairly simple for you. You've done this before. But when you have it where you've got a square here and you need to get rid of the square, remember the inverse of squaring something is taking the square root of it. So what we're going to do is we're going to take the square root of C squared and the square root of 130. So that would be C equals the square root of 130. Now when we're doing these, I want you to simplify the square roots into the simplest form, but 130 doesn't have any any perfect squares as factors. So 130, the square root of 130 is the smallest number that you can have. Alright, and here's our next one. So in this one, we don't know one of the legs. So we've got A squared plus B squared equals C squared. Now remember, C is always the hypotenuse, always the longest side. So we have 8 squared plus B squared equals 16 squared, 64, and 16 squared is 256. So we're solving equations, so we're going to subtract 64 here, subtract 64 here, and I'm okay with you skipping a couple steps here, but you do need to kind of show me your thought process. So B squared is equal to 192. Alright, remember we want to get rid of that square, so what we're going to do is we're going to take the square root of B squared and the square root of 192. So that gives us, I'm going to write it over here, B equals the square root of 192. Alright, so we need to think about, does 192 have any perfect squares as factors? It does actually, so it's the square root of 64 times the square root of 3. We know that the square root of 64 is 8, so our final answer is 8 times the square root of 3. And a good trick that I showed a couple people in class is that if you have your calculator, if you go to the y equals button and you put the number, so 192, if you do x divided by 192, it'll give you all the factors, or sorry, 192 divided by x, it will give you all the factors of that number, and you can pull out the perfect square. So that just makes it a little bit easier. All right, so let's do something a little bit more challenging. All right, so this is one where you have to draw the picture. So it says Harry the hamster walked 9 inches north. So we're going to say he starts here and walks up 9 inches. Okay, so I'm going to label that 9 inches. All right, then it says he walks west 12 inches. So he's going to walk, oops, let me make that better. He's going to walk this way, make it a little bit longer, 12 inches. Okay, and then he walks south 14 inches. Now, we know that it's going to be longer than this 9, so we'll do 14 like this. It's not to scale, but it's close. All right, and then he walked 5 inches east. So now I'm going to do, oops, 5 inches east. Okay, so there's my 5 inches. All right, so it wants to know, find the distance to the nearest tenth of an inch that Harry is from his starting point. So his starting point is right here. His starting point is right there, and his ending point is right there. So they want to find out how far away is he. So you want to know this distance right here. Okay, so if you notice, we have got something like a rectangle. Okay, if he's walking northeast, south, and west, we've got a right triangle there, or sorry, right angles there. Okay, so if we take and continue out this line, let's change the color. Okay, if we change this line, just so, and we go out here to meet that side, and then we go down here to meet that side. All right. So we knew that this first one, this is 5. All right, so this side is 12. That means this side has to be 7, right? Because 5 plus 7 is 12. And if this distance is 9 right here, and it's 14 on the other side, we know that that has to be 5 inches. So now we've got our A, our B, and our C. So A squared plus B squared. Okay, so we're finding the hypotenuse. So 7 squared, 5 squared. So 49 plus 25. So that would be, 74 equals C squared. Okay, remember to do the opposite of a square. You're going to take the square root. So that means that C is equal to the square root of 74. Now typically when it tells you in the nearest tenth, then that's the time that you don't have to leave it in radical form. Because when you're doing distance, you want to have it as a distance. So if you use your calculator to find the approximate distance, because it's not exact, the approximate distance is going to be 8.6 inches. Okay, so now we're going to talk about the converse, right? That's kind of like the opposite. So the Pythagorean theorem states is that if, I'm just going to do abbreviations, if a right triangle, then A squared plus B squared equals C squared. So those are if-then statement. If, then. Okay? So converse, we're going to switch those two. So the converse is going to be if A squared plus B squared equals C squared, then is a right triangle. Okay, so that's just showing you, so if, then. That's just showing you that you can have two scenarios. They can tell you that it's a right triangle, therefore you know that A squared plus B squared equals C squared, or they don't tell you that it's a right triangle, but because a squared plus b squared equals c squared, you can prove that it's a right triangle. So it's just going backwards depending on which information you have. So on these, they're just asking you to prove whether or not these three lengths could form a right triangle. So the first one is 6, 8, and 7. Right, important thing to remember is that they're not always going to give you A, B, C in order. The hypotenuse C is always the largest one, so I'd get into the habit of circling that. So if this is a right triangle, that means that 6 squared plus 7 squared should equal 8 squared. So that gives us, I'm going to skip a step. If you do the math, you get 84 does not equal 64. So that means this is not a right triangle. Okay? The next one is 40, 9, and 41. Okay, again, we want to know, make sure we have our right C. So there's our C. So we've got 40 squared plus 9 squared, oops, forgot the 0, equals 41 squared. So if you do that math, you get 1681 is equal to 1681. So that one is a right triangle. Okay, so it's just important to know what information you need to prove if it's a right triangle or if you have the right sides to make a right triangle. Okay, now we're going to use information to see if we can determine whether or not it's a right triangle, which we just talked about, or whether it's an obtuse triangle or an acute triangle. Okay, so your table looks a little bit different on your paper. It's got that column that says type of triangle. I'm going to have you do that on your own. But what we're going to do is we're going to take the side lengths. So this first one is 6, 8, 10. I'm going to do the first and second one for you and then have you do the other ones. So what you're going to do is you're going to do a squared plus b squared. I'm going to skip the step. A squared is 36 and b squared is 64 because that's 6 squared and 8 squared. And we know 100 squared is 100. And if you add 36 and 64, that's 100. So 100 is equal to 100. So obviously, if a squared plus b squared equals c squared, then you know for sure that that one's a right triangle. So under type of triangle, go ahead and write right. All right. So the second one, we've got 6, 8, 11. Okay. And we're going to do the same thing. So we've got 36 plus 64 equals 11 squared is 121. Okay, well, first of all, it doesn't equal that. Okay, 36 plus 64 is still 100, so 100 is less than 121. Okay, so what I want you to do is for every single one of those numbers, I want you to find the a squared plus b squared and say whether or not it's greater than or less than the c squared. And then what I want you to do is see if you can make a determination which ones are obtuse and which ones are acute. And just kind of use logic and go through it like that. So go ahead and pause it, fill that out, and then come back and check your answers. Okay, so here's the rest of the rest of the table filled out. And if you notice, or do you notice, is there a relationship between the a squared, the b squared added together, and the c squared? We already know that when it's equal, that it's going to be a right triangle, so it has three choices. Either it's a right triangle, or it's an acute triangle, or it's an obtuse triangle. So what do you notice here? All of your obtuse ones, which is this one's obtuse, and that one's obtuse. So we have this sign. When you're adding, let me change the color on that. When you're adding the A and B together, it is less than the C squared. And then when you have the acute, then you've got a greater than symbol. Okay, so in that table, you're going to fill out, I'm going to put on the next screen, but what I also want you to write down is that I want you to just kind of think about, why is that true? Why is it less than C if it's obtuse, but greater than if it's acute? Because you kind of think, just by thinking about it, that it has to be greater to be obtuse and less than to be acute. So I kind of want you to think about that. Okay? Alright, so here's our good old if-then statements. If a squared plus b squared is greater than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then the triangle is obtuse. And of course, if a squared plus b squared is equal to c squared, then the triangle is right. Okay, so I'm going to do the first one, 16a, with you, and then I want you to do the other 4 just to kind of get practice, and then you can start working on your assignment. Come see me if you have any questions or you need something clarified, and have a great day. Let me go ahead and, well, I shouldn't have said that because I'm going to do the next problem. Okay, so this one wants you to basically state, if I give you 3 sides, so I've got 7, 14, and 15, and it wants to know what type of triangle is it. Okay, again, I would get into the habit, especially for those of you that just make those silly mistakes, circling your hypotenuse, okay, because your answer will be all wrong if you don't. So, again, I'm okay with you doing a couple steps, so if you just want to go straight to 49, because that's 7 squared, and straight to 196, and then we know 15 squared is 225. And when you add them together, oh, I didn't add them together, hold on. Well, when you add them together, you know that a squared plus b squared is greater than 225. So remember, if it's greater, then it's acute. Okay? So I'm going to go ahead and do B, C, and D. Well, you do them and then pause, and then I'll have the answers here on the next screen. Okay? All right, here are the answers for those 3 questions. And just notice how I circled the largest number to show which one was the hypotenuse. On the third one, you might have to go to your calculator and double check that the square root of 31 is in fact smaller than 16, even though common sense tells you that it is, obviously, because it's around 5 point something. But anyways, and once I went through it, all I did is I circled the inequality sign, because obviously if it is equal, it's going to be a right triangle. And don't let the square root confuse you. Just because there's a square root in the answer doesn't mean that it can't be a right triangle, which this one showed you, which you probably thought it wasn't. So just look at that box at the bottom. It's just, giving you another way to remember whether or not it's obtuse or right. And remember, geometry, a lot of it is you do have to memorize certain things, and if you can memorize this and also just understand why the smaller c squared makes it be an obtuse triangle and vice versa, that it's going to work that way. So anyways, I hope you guys liked the video. It's the first one since the break, so I might have been a little rusty. I apologize for that. So just go ahead and start on your assignment, and if you have any questions, come and see me. All right, you guys have a great day.